charm, elegance, symmetry, color, strangeness. Believe it or not, these are the actual words physicists use to portray the most basic scientific picture of matter. Their field, quantum physics, describes how the world really works, down to the composition of atoms, up to the structure of the universe. What they see is breathtaking, but it could seem like fantasy or magic, because quantum physics doesn't look like anything we've ever seen before. Next, on Closer to Truth, why is quantum physics so beautiful? Welcome to Closer to Truth. I'm Robert Kuhn. If you think quantum physics sounds hard, it's even worse than that. Nobody in his right mind, I'm told, would do a program like this. But quantum physics is real and relevant, and just about everyone can appreciate its profound beauty. We've invited 5 world-class physicists to give their impassioned portrait of a new reality. So tilt your head, and it won't be so hard. My bet is that you'll get it and like it. Dr. Leon Lederman, Director Emeritus of the Fermi National Accelerator Laboratory, won the Nobel Prize in Physics. Dr. Stephen Koonin is Vice President and Provost of Caltech, where he is Professor of Theoretical Physics. Dr. Andrei Linde, an innovative astrophysicist from Russia, is professor at Stanford University. Dr. Charles Buchanan, professor of physics at UCLA, teaches science and the human condition. And Dr. Gregory Benford is a leading science fiction writer as well as a working physicist. Leon, pretend I'm your grandchild. How would you explain what you do?
Well, how do I explain what I do? Kid, look, listen closely. I try to find out some of the mysteries, things we don't understand about the world. We want to understand how the world works. You have your world, you're interested in your world. I have my world. My world happens to be the world, the universe. How does it work? Why do things happen the way they happen?
And Grandpa, so what do you do to find out?
Well, we do little pieces at a time. Sometimes we have a simple problem, like how did the world begin? Now, Andre's the expert on that, but there are a lot of things he has to know.
I heard you were there, though.
I was there, that's right, that's right. That's, of this audience, I'm here because I was there. I even know that I knew the Dead Sea before it was sick. So it's important to have evidence. But we do know that that the universe began, and at the beginning, it was all particles. And particles is what we do in our laboratories. I do my research at the Fermi Laboratory, 30 miles west of Chicago. Everybody's invited. It's an open lab. And scientists from all over the world come there to address issues of the most primordial building blocks.
Steve, what are some practical applications of quantum physics?
Yeah, well, you know, the incredible thing about quantum mechanics, there are many incredible things, but one of them, at least to me, is that it really works. It is the theory of the universe. It describes what's going on here on Earth, that it describes what happens in the early universe that Andre studies. And so when we think about how those building blocks that Leon was just describing fit together to make the world around us, we use quantum mechanics to describe atoms, nuclei, molecules, light. It is the theory of the world. And so it's not surprising that we see it in many everyday occurrences and many everyday applications.
What's a couple examples?
Yeah, an example might be the lasers that you see in a compact disc player or the supermarket scanner.
Great. Chuck, how do your non-science undergraduate students react when you deal with issues in fundamental physics?
Well, it's a lot of fun to try to do that. One thing that I particularly enjoyed recently was an honors collegium seminar of 21 students, one physics professor, myself, and 2 biology professors, one on molecular biology and one on genetic evolution. And we basically started with the beginning of the universe through the formation of solar system, supernova for heavy elements, etc., and then through evolution of life on Earth up to the human being. The title was Science and the Human Condition, and the question was sort of, where did we come from and what are we?
And it all related back to the fundamental particles that Leon
Quantum
plays
mechanics,
around with.
quantum mechanics is there everywhere throughout this whole evolution.
Right.
And yes, you can communicate this sort of excitement and view to undergraduates.
Andre, how can the study of something that's so minuscule have an impact on the unbelievably large cosmos?
Well, some years ago, it would seem impossible that quantum mechanics have any relation to something as big as the universe, because quantum mechanics is supposed to be important for only very, very small particles.
Right.
Well, during the last 20 years, the status of cosmology changed. Instead of standard Big Bang theory, we are applying right now something else, which is called inflationary theory. And this theory claims that all our universe started from the tiny spot of a size smaller than an elementary particle. And then it expanded incredibly fast. And during its expansion, small quantum fluctuations, invisible here, they become huge, and they build galaxies, and they are continuing building different parts of our universe.
So what you're saying, in essence, is that what's happening in the microstructure of quantum mechanics at the very small is actually responsible for creating the entire universe.
Yes, indeed, what happens is that you cannot understand galaxy formation if you do not know quantum mechanics.
Greg, you're a plasma physicist, but you're also a poet, rumor has it, and it's to the poet, not the physicist, that I want to ask this question. How does a poet see quantum physics?
Think of quantum mechanics as being like a French Impressionist painting, luminous, vibrant, of, say, a cow. But the miracle is that the cow gives milk. And real paintings don't. And that's why the universe is better than any metaphor you can think of, even though we trade in it.
There's nothing like the real thing.
Right. And as Andre was saying, you know, sure, you think, boy, how can you explain the universe with little quantum mechanics, which is supposed to act on a small scale? But remember, the universe was once this big.
Smaller than that.
Actually, yeah, this is an approximation. Well, I said in a poem once, all that bang and sass beneath an eyelid's underpass. That is, that everything was once ruled by mechanics that is not like the categories we exaggerated chimpanzees have. And therefore, we say, well, an electron is like a stick or a stone, and it's like a wave, which means, in fact, it's neither of these. It is something that we don't have a good category for. It's saying to us, you know, you're great chimpanzees, but you're not ready for prime time as far as your metaphors go.
All right, let's actually now define what a quantum is.
Wait,
Leon, I'm still your grandchild.
Yeah, I know. Just go clean your room. But I just wanted to comment that the particles we study are studied in atom smashes, or particle accelerators, but media says atom smashes.
Yeah.
The Big Bang was an atom-smashing laboratory with a totally unrestricted budget. And that's what we like. And it's out of that we get the beginning, and out of all these events that Andre described so briefly, oceans roiled, and out of the oceans things crawled, and eventually here we are, wondering how the universe began.
So now, tell me what a quantum is.
Well, it characterizes the difference between quantum theory and the world which we know as grown-ups and humans, that was clarified for us by Isaac